In this short video, you will learn the very basics of a drone and its components. At the end, you will have a simple but wide picture before starting the hard work in the transversal project. As you know, there are many types of drones. Even in the group of multirotors, we have a variety of possibilities depending on the number of motors. In our transversal project, we will use the quadcopter, or also named quadrotor, like this one, with 4 motors. And that will be represented by this drawing throughout this video. This is the head of the drone. The basic movements of the drone are implemented by controlling the speed of the different motors. For instance, if we want the drone to take off, then all the motors, all the different motors must rotate fast at the same speed. If we want to go forward, then the back motors must rotate faster. If we want to rotate left, then motors 1 and 2 must rotate faster. Of course, many other possibilities can be found. Any combination of rotation speeds are possible. In this case, for instance, if these numbers represent the rotation speed, then the drone will move in that direction. Multirotors use brushless motors. In these motors, the rotation is achieved by controlling the magnetic fields generated by the currents supplied to the motor. To control the rotation, you just adjust the magnitude and direction of the currents injected into the motor. A brushless motor usually works together with an electronic speed controller, ESC, which facilitates the control. The ESC receives a pulse width modulation signal, PWM, which controls the speed. When the width of the pulses is high, then the speed of rotation is also high. There are many other devices that can be controlled with PWM signals. Some of them are sometimes used to build drone platforms, for instance, group of LEDs or servos. There are many ways to generate PWM signals. You can do it with an ad hoc circuit, or with a CPU like the one in the Arduino or the Raspberry Pi, or through radio control. That is the usual way in the case of drones. When using radio control, the transmitter generates a radio signal that the radio receiver converts into a PWM signal that is connected to the device. Using the different actuators of the transmitter, sticks, switches, or knobs, you can control the form of the radio signal and therefore the form of the PW signal, for instance, to accelerate the motor. Normally, a radio transmitter can generate in parallel several radio signals through different channels. These signals are used by the receiver to generate separate PWM signals. To control several devices in parallel. So you can accelerate a motor with one of the sticks of the transmitter and change the position of the servo with some of the switches and increase the brightness of the LED with one of the knobs of the transmitter. To do that, the transmitter joins the radio signals from the different channels into a single signal using the frequency division multiplexing technique. The receiver will multiplex the signal into the different PWM signals. In a drone system, motors and servos are not controlled directly by the receiver as explained before. It would be impossible to operate the drone from the radio in such a way. A drone system has a flight controller that generates the required signals to control the motors, to implement the basic movements such as elevate, go forward, or turn right. Now when you move a stick in the radio, the generated radio signal is converted into a PWM signal that the receiver sends to the controller. That will change the speed of all the motors to elevate the drone, for instance. Other sticks or switches can send similar orders to the drone system to land the drone or to turn left or to move back. In a flight controller, the flight controller usually also implements stability using built-in devices such as barometer, accelerometer, or gyroscope, depending on the flight mode. For instance, the flight controller can generate signals to maintain the altitude of the drone even if the operator is not touching the radio. Some flight controllers are really sophisticated. This is the case of an autopilot. Besides doing everything we have just explained, the autopilot is able to execute autonomously a flight plan, moving the drone along a series of geolocalized points without intervention of the drone operator. In this case, we need a ground station equipped with adequate software that allows us to design flight plans, send the plans to the autopilot, and receive flight data. A good example of this kind of software is Mission Planner that we will use in the Transversal project. Finally, we can even install a computer on board that can change the flight plan if something happens. For instance, in case the computer identifies a specific shape in the pictures provided by the onboard camera, it can instruct the autopilot to land immediately the drone. So this is all by the moment. During the transversal project, you will meet all the elements you have seen in this video. You will have to learn much more about each of them and use them to build a drone platform ready to execute basic missions and not so basic ones.